Hello, and welcome to episode 22 of TGIK. Let's go ahead and get started. I've learned my lesson. If folks can, in the chat window, can let me know that you're here and that the sound is coming through, that would be awesome. I don't want to talk for like 20 minutes only to find out that nobody can hear me talk. Well, it's kind of, normal. It's kind of how things work, right? So anyway, let me get started. So my name is Joe Beda. I'm the CTO of Heptio. We're a startup focusing on bringing Kubernetes to new. Oh, no audio. So I heard no audio. Shoot. Shoot. Can you hear audio now? Sound is good? Oh, sound is good. You could hear. All right, let me switch back to my other mic. I was switching mics. Yeah, it said it was sending, but never trust these things, right? You got to do full integration tests. If I just look at the green bar, that's just a unit test. That's not good enough. All right, so there we go. Yeah, so my name's Joe Beda. I'm CTO of Heptio. We're a startup focused on bringing Kubernetes to the enterprise and beyond. Also, one of the people who started Kubernetes while I was at Google about 3 or 4 years ago. And so TGI Kubernetes, is a series of video streams that I then have recordings where I talk about interesting things that are happening in the Kubernetes community, go through some new projects, review some topics and go into some depth and demo those. I've done some live coding, some stuff like that. So so that's the plan today. So first of all, I want to say hi to folks. So Steve, who works with us at Heptio, thanks for tuning in, Steve. Fernando, Marky, Hans from Sweden, good to see you. Joe, nice to see you. Oh yeah, you're mentioning the beard. I get lazy and then the beard gets bushy and then I like zzz, and then it's like Kiwi mode where I'm just like one layer of fur all over. And let's see, Bismarck, Yaron, nice to see you. So Yaron and Aaron, and I'm probably butchering your names, I apologize, are from the company that's driving the project that we're going to be talking about. So I'll get into that. So thanks for joining us, folks. Let's see. So we have, so Chris, who's in the room next to me here, is hanging out with us. Colm. So awesome. Lee, another Chris. Let's see. Alex is in Miami. Federico in Sweden. Fernando in Brazil. I love the worldwide thing. It's like, thanks for spending your Friday nights or Saturdays mornings with me. There's not a lot of folks who are earlier than this. So yeah. All right. So so today the topic is we're going to be covering Nuclio, which is a serverless framework that works on top of Kubernetes. And it's part of a larger platform that and I'm gonna screw up the name here. Let me look at it. That this startup Iguazio, and hopefully I'm not doing it too bad. That this startup Iguazio is building around sort of it's part of a data processing platform, real-time data ingestion, servicing type of thing. And I think it's going to be interesting to sort of compare and contrast this with some of the decisions made in some of the other serverless frameworks on top of Kubernetes. How much does it integrate with Kubernetes? What are really the differentiators around being sort of real-time, high throughput types of things? So that's, I think, going to be super, super interesting. So that's what we're going to be digging into today. And like I said, we have from Iguazio, we have a couple of folks on the line in the chat room there who can, if I totally get myself wedged, hopefully we can work our way out here, because if you've watched this before, I don't have a script, so I just kind of go through and explore technology and oftentimes do things in an interesting way that folks don't expect. But we fix it. And we get through the other side. So yeah, so before I do that, I do want to spend a couple of minutes talking about sort of new stuff that's happened in the Kubernetes world. If there's something that you'd like an opinion on, go ahead and put it in the chat and I'll try and get to it. Otherwise, I think it's been a pretty quiet week. Oh, David from Croatia, nice to see you. And Baca from Alki. Is that Alki, Seattle? And Eduardo from Costa Rica. So good to see y'all. So it's been a pretty quiet week in the Kubernetes world, I think. I don't think there's been a lot of huge announcements, at least nothing that I've seen that's bubbled to the top for me. The one thing that, I guess there's 192, so there is a point release. And, let me Here, and let me switch to my screen here, and I'm going to pull up, if we look at, well, that's the releases. So look at this. So, okay, so we'll go releases here, and I think this usually has a link to the changelog there. So 192, so let's see what landed in 192, because I think that is interesting. There are no release notes for one. There's no changelog since 191. Yeah, so a lot of times these are the types of things that you'll see. I hadn't heard of anything that was super duper critical. Oh yeah, I'll talk to, okay, so Chris has something there. So I think a lot of times what these end up being, the patches in these point releases are more specific scenarios, some stuff that broke. And so things like, authentication for vSphere, like, it's the type of thing where if that hits you, you really, really care about it. But if not, it probably misses you. So this quota thing, that seems like that one might be interesting if that's hitting you. etcd, there might be some critical issues with etcd that really caused this, so might be worth looking on there. Graceful shutdown for Kubernetes components. So that looks like that's actually a really good fix depending on where you need it. But most of these look like they're cloud provider specific. And then 191, I hadn't actually looked to see here. Garbage collection race conditions. So this one's probably pretty critical here. Yeah, so some good fixes coming in. Yeah, I mean, unfortunately, we're kind of in this world with Kubernetes where I don't think we get enough folks really pounding the pre-release, the alphas and the betas for these releases. And so generally, like, we have a couple of point releases that soon follow after a regular release that fix some issues. It's a lot of work goes into preparing these releases, but one of the keys, and I've said this before, one of the things that makes Kubernetes so compelling is that it can work in so many different environments. And what that means is that there's a bunch of integrations, there's a bunch of things that don't necessarily get all this sort of pre-release coverage that we wish they would. So how many folks are running 19X? So you know what? That's a fascinating question, Lee. Or Lamatti, usernames are always tricky. It's a fascinating question. We don't know. We don't know how many people are running Kubernetes. We don't know how many people are running which version of Kubernetes. One of the things that as a project we struggled with is, should we put any sort of version tracking phone home into Kubernetes? And I don't believe that anybody's actually done that yet, at least nothing that I've seen. And I know it's something that's been discussed, but obviously there's a lot of sensitivities about anything that phones home. And I think making sure that we do that in a responsible way where it doesn't take people by surprise and they have the right opt-out type of things and stuff like that. It's not unheard of. I think if you look at something like, I believe most of the HashiCorp products have a phone home mode where they'll actually send some metrics back. We don't have anything like that here for Kubernetes. And Josh says providers like GKE should have some good numbers. Well, the thing is that like the Google folks with GKE, they get to guide their users on when upgrades are available, and they can essentially send email or say we're going to deprecate. They can do some things to really move stuff forward. So I think there's a real question in terms of like how far back and how old are people running versions of Kubernetes? Where, what does it take to upgrade? How fast do people upgrade? Is there a correlation between cluster size and which versions people are running? I think those are all interesting questions that we'd like to get answers to. We just don't have the data for that. So I don't think we actually have I don't think I can give that answer, unfortunately. But I think it's something that, getting a good idea of sort of what's acceptable, what people think is reasonable from a privacy point of view, would help us to build those mechanisms. Then somebody has to go off and build it. All right, so that's 192. So some really good stuff going on there. So the one thing from Heptio's point of view is we released Contour version 030, so 0.3. Now Contour is a Heptio project. Dave Cheney, who is like go curmudgeon extraordinaire, I love Dave, is driving this primarily. And what this is an ingress controller built around Envoy. And so Envoy is really built from the ground up to be super dynamic. And so this is an ingress adapter for that just does ingress. And so it's really focused on how can we use Envoy for getting stuff into the front door versus something like Istio, which is service mesh, where the primary focus is really about connecting workloads and sort of delivering the value on the mesh. Contour is really about how do we get data in from the outside. So that's the big feature that comes with Contour v3 is TLS support. And the reason why that's coming now is because S&I support, so this is the way that you can pick a certificate based on negotiation and do virtual hosting with TLS. Is only just released in Envoy. It's actually a really new feature in Envoy. And to do that, you have to start talking between Envoy and sort of the management server for Envoy using gRPC instead of the JSON APIs. And so there was a lot of plumbing that needed to go on so that we could actually start activating the new support. So this is the V2 API for Contour, or for Envoy, that this stuff is using right now. And then along the way, Dave added support for some annotations, the gRPC API, like I mentioned, and there's some other good support here, like the proxy protocol is now supported, which is really exciting. So let's see. So Lamati says, anyway, doing a TGI session Envoy. I would love to. I'm not a super expert on Envoy. I did do one on Contour earlier. I think it might be, it'd be interesting to sort of really dig into Envoy, look at some of the options. Like I said, I'm not an expert on it, but I think Envoy, the design and sort of the way that Envoy is thinking about being API driven is really, really interesting. And so I think it definitely is something that might be a good deep dive. So any perf comparison with Nginx ingress? That's a good question, Yaron. I think there's a couple of interesting things going on there. And the Nginx ingress stuff is definitely it's a more mature, sort of tuned thing. And Nginx at its core is a highly tuned piece of code. Now, when I've talked with Matt Klein, who's the author of Envoy, I mean, there is this feeling of like, do you chase performance at the cost of flexibility and maintainability and API drivenness? And I think Envoy is still very, very performance. It's C++ code base. I think when you're dealing with sort of raw packets, that's one of those reasons where C++ is maybe very well appropriate, and it's a really clean C++ code base. But Envoy wants to really balance. It has very good performance, and it wants to balance that with having the flexibility with this API-driven configuration mode that Envoy has, which is really, really interesting. I think one of the things that I think for me, I think folks should take a close look at is there's the free version of Nginx, and then there's Nginx Plus, which brings on a whole bunch of extra features, and that's a paid thing, and it's not cheap, right? And so it really depends on your business needs. Well, it turns out that at this point, my understanding is, and I don't have any firsthand knowledge, but my understanding is that those are largely two different code bases. And so what you'll see is a lot of the features to deal with hyper-dynamic environments, live reloading in responsible ways, a lot of those features go into Nginx Plus. And so that means that to get Nginx to sort of reload, it ends up being an intrusive, expensive, sometimes broken, sometimes kludgy way to actually essentially, what the Nginx controller does is it writes out a config file and then, essentially hups Nginx to have it do a reload of that thing. And there definitely have been issues, before where that reload didn't always happen in the way that you want, or things get stuck, that type of thing. Whereas the way that Envoy is built is the process itself, you can program it and it reaches out and talks to another server to get its configuration. So it's built to be dynamic and programmed from the outside from the very, very beginning. And so that's one of the reasons why we're investing in sort of building the ecosystem around Envoy with Contour. And we have some exciting stuff coming up with the future versions of Contour that really look at more sophisticated ways of doing ingress and load balancing in general. And you know what? I think I'm gonna pull this up because this is, and I was just looking at this the other day. So Matt Klein, like I said, is the person. He's local to Seattle here. who wrote Envoy. He wrote this. It's a long blog post, but he wrote this fascinating blog post on sort of modern load balancing and how it works. And I read through this, and I'm like, yeah, the patterns that Google uses fits into this, and we're seeing this pattern repeat itself in a whole bunch of different places. But the idea is that you end up with, and he talks about sort of mesh, sort of client, sort of internal load balancing versus external. And so we're definitely looking at Contour to be a piece of the puzzle for sort of, the modern load balancing like this. Also, if you look at, I did a TGIK on ingress with TLS where I did use the Nginx ingresses before we had Contour. And if you look at that, you'll see that I do go into some of the same detail that Matt goes into here. So this is some interesting stuff, and I encourage everybody who's interested in understanding sort of modern load balancing, how it's done at scale. This blog post from Matt is definitely where it's at. So you mentioned earlier, TGIK, that someone wrote a container-aware load balancer that allows you to register pods as they come online. Did you happen to find any more details about that solution? I'm not sure which one you're talking about there. I think, I'm not sure which one you're talking about. I mean, generally in Kubernetes, what happens is you use the service object to identify the set of pods and that you want to talk to. And then with health checks, that ends up becoming online. And then the ingress system actually keys off of that. So I don't know of anything that works outside of that bandwidth. Now you said, okay, so eBay. Gosh, is eBay? I don't know if eBay's doing something. I have heard rumors. So one of the things that you'll see here, and I don't want to out anybody, but if you look for maglev, which is this other load balancing system, and this is a pointer to the paper on that. This is an L3, L4 load balancer. And so generally, if you read through that article, you'll see that blog post is that generally most folks have something that works at the L3, L4 thing that really sort of sprays load to a bunch of L7 load balancers. And so you create this two-tier system. Maglev is a software, high reliability, L3, L4 load balancer. And this is the thing that allowed Google to kick these sort of like outrageously expensive hardware load balancers to the curb and replace it with a software system. I have heard rumors that some folks are working on a open source sort of thing inspired by maglev. Really interested to see that stuff come up. So that's something to be aware of also. So anyway, so that's what we did with Contour. Super exciting. The cluster that I have set up ready to go with Nuclio is using Contour. Hopefully that'll work when we start doing the ingress stuff. Otherwise, we might have to go through and start hacking some stuff. That might be interesting. So we're going to go a little bit off script there and see what happens. The last thing I wanted to do, and Chris, I don't know if you have a link for me to point to, but one of the things that Chris has been doing, so she just joined us at Heptio from as a developer advocate. And what she's been doing is starting some open conversations, some open community calls around what does it take to move legacy monolith workloads into this new world, into Kubernetes, into containers. And so she's really been collecting a lot of experiences, a lot of gaps around that. And so there's regular calls there. In fact, here at twitter.com, we did have, I do know that we just had a Twitter post on this. So here you go. So here is Chris's post on that. And so if we click through here, she wrote a blog post on this. So yes, so I will include all this stuff in the show notes, but if you're interested in, exploring the problems, the goals, the tools that we can do. Yeah, you can't paste links in here, Chris. It's one of the sort of YouTube weirdnesses because otherwise these things become spam magnets. Yeah, so like I think then, definitely get involved here, and I'll put these links in the show notes too so that folks can actually pay attention there. All right, so I spent 20 minutes talking about stuff that actually was not the main topic that we're trying to handle today. And I do this every time. One of the things I'm going to do, though, in the show notes is I'm going to find where I actually start talking about Nuclio. And I'll say, hey, if you really want to just jump to that, I'll have a link in the in the description for folks. I'm going to learn my lesson there, so that'll be good. Okay, so let's take a look at Nuclio. So, like I said, Nuclio is the project is being driven by Iguazio, and so they're doing a whole bunch of stuff around sort of real-time data platforms. I haven't honestly sort of wrapped my head around everything that's going on there, but it definitely looks interesting. A part of what they're doing is this serverless framework that can run on top of Kubernetes. Now they're sort of quick getting started is to run this stuff with Docker on a single machine. I think that looks interesting, but I think, obviously if you're going to run this stuff at scale, you want to run across many machines and get resiliency there. So we're going to start digging into how to deploy this stuff on Kubernetes. And then I think we're definitely going to want to dig in a little bit and understand what it is that may make Nuclio different from some of the other serverless platforms that are out there. And I think I understand, but I'm going to say some stuff, and then I'm going to be looking for Iran and Euron to correct me and tell me I'm wrong. But let's at least sort of like get started with it and see what happens there. So one of the things that we have here is we have getting started with Nuclio, and this brings us to this page here. And I actually already had that open, so let me close that other tab. And I think one of the interesting things here is that this starts with even deploying Kubernetes or getting Kubernetes up and running. And so, or actually it did before, but it looks like, I think you all just, let's see, I love this. Okay, updated 27 minutes ago. You guys are moving the cheese on me. I did a little bit of pre-flighting and reading stuff, but okay, so let's go through this. So we already have a Kubernetes cluster. I'm going to be using one of our quick start clusters on AWS. And so again, it's like one of these things where I think getting something like this running with Minikube is definitely an interesting way to go, but actually looking at a real platform is also going to be interesting. So one of the things here is if you already have a Kubernetes 1.7 cluster, you just need to make sure that you have access to some Docker registry. If you'd like to use the Docker Hub, specify this, and then or we can do a private registry. I was going to play with this. Now, why don't we... why don't we go ahead and we're going to use the Docker registry, like my own personal Docker registry thing here, just to keep stuff simple. I think this is one of those things where, and this might be a good topic for a TGIK, is actually go into all the different ways and how sort of like pointing things at different registries work. And I can do a little bit of homework there around local registries. We can play with GKE, or the Google registry. We can play with the Amazon registry. That might be an interesting topic. Because it's like one of those things that's fractal. It's actually more complicated than it should be. And so that might actually be something that's worthwhile. All right. And then it says, okay, just do a couple of kube control applies. So this is, curl pipe to sudo bash. But we're not going to do that. We're going to actually dig a little bit deeper here. So the first thing I'm going to do is I'm going to clone the repo. And so... let's see, is it coming down? Okay, we'll get that going for a little bit. That's right. That's my move. Curl pipe to sudo bash. Yeah, no, I think it is a good habit though when you're playing with stuff like this to really understand what you're getting yourself into before you just install stuff. Well, it depends on where you're running it. I think like right now I'm running this, and if I totally did something, this is an isolated cluster. I could take this thing down, no harm, no foul type of thing. But especially if you're evaluating something from the point of view of running it on infrastructure that you care about, take a closer look in terms of what you're actually going to be doing. So let's see. Why is GitHub download so slow? You know what the problem is? It's hosted on Kubernetes. That's the problem. All right, well, while I'm waiting for this, check out the cool TGIK over here. You see that? So there's this feature in iTerm 2 on the Mac called a badge. And if you do these like special escape codes, you know, and send it some like base 64 encoded stuff, you can actually go ahead and set this like cool thing. So if like you're dealing with multiple windows and multiple servers, that's actually something you can do. All right, so let me bring this up in VS Code. And then the file that we're looking at is hack Kate's resources controller. All right, so we're going to go ahead and look at that. So what is this? This is going to bring up a plain old deployment, so that seems easy enough to do. And this thing is just one replica of this, so there's no HA on this stuff. And then there's the, let's see, and then what is the other thing we're going to bring? The playground. We're going to bring up the playground. So let's look at this. So this is going to be another container. Okay, so now this here, this is like, this is dangerous here. So just so that you all know, there's a couple of things going on here. Number one, this is assuming you're using Docker, which is not always a valid assumption. I think pretty much now at this point it is, but it won't always be a valid assumption. And then essentially what this is doing is it's going and it's reaching behind Kubernetes back and talking to Docker directly. This is something that you should be very careful about when you see this. So it turns out that the reason why, my guess is that the playground's doing this is so that it can build Docker containers, Docker images, and push those. And it turns out that there's actually no good way to build a container image on a Kubernetes cluster. All of the ways that building on that do this really need a set of permissions in the cluster that is very difficult to actually restrict and make safe in terms of being able to hit, you know, other people. And so this is the type of thing where I think, you know, getting a white paper out on this and really guiding people here would be useful. It's not insane when you do need to do it, but I think best practices if you were going to do something like this on a production cluster or a multi-user cluster is number one, recognize that this is launching stuff behind the kubelet's back. And so when you start doing resource accounting and quotas and stuff like this is launching containers without going through the entire Kubernetes permission stuff. It's just going through and launching stuff directly with Docker. And then access to the Docker socket is roughly equivalent to having root on the machine, right? And so any other type of policies that you might have that try and prevent one container from infiltrating another container, all that stuff goes out the window with this. In addition, anybody who has access to writing a Docker file may actually find ways to actually have root also, or if you give them, you know, ways. So you have to really think about the attack surface there. If you do need to build, containers on a cluster, what I would do is I would have dedicated nodes. I would run things that are talking to Docker directly on those dedicated nodes. I would probably set up those dedicated nodes to actually rotate and actually sort of like bring them down and recreate them if you're in a cloud environment on a regular basis. And if you can, I would have, instead of just taking a plain old Docker file, which is, again, is like essentially has root, I would have some higher level description of what you want to put in the container, and then generate the Docker file from that, or have something that actually can parse the Docker file and say, hey, this is doing some sane stuff here. You have some whitelisted set of commands. And so I think if you can constrain the data that gets to the Docker daemon, you'll actually be a lot safer. Okay, so but for now, like we're just going to go with this. This thing's doing an end run around Kubernetes. We'll live with that, and then it's creating a service with a node port. Okay, and so yeah, let's go ahead and I'm going to go ahead and launch both of these. So we were Nuclio hack. So the hack directory, I'm the one who started the hack directory in Kubernetes, but I borrowed it from Docker because at one point all of Docker's build scripts were actually called hack. And so I'm like, that seems like a good pattern. Now it's kind of a little bit like, it's a little bit embarrassing maybe. I don't know. I don't know. Okay, so kube control. Oh, and what namespaces? So these are going, so there's no namespace here in terms of what these things are doing. And there's no RBAC-ness going on here. So let's see if we can actually see. Nobody has said to do anything with RBAC yet. I know that there were some instructions at one point about RBAC. So let's actually dig in a little bit here. No, that's not it. No, I know the old guide had some information about RBAC and running this stuff with the right service accounts. Let's see if I can grovel around in default cluster admin. Okay, so this is like so this is the most dangerous way to actually sort of turn off RBAC without turning off RBAC. So what this is essentially doing is it's saying I'm giving the default service account in the default namespace cluster admin. So essentially give that thing root. And so this is very, very close to essentially turning RBAC off altogether here. Now, what you could do is you could change this to give it admin within that namespace, which would be a little bit more scoped. But right now, essentially, this is like all permissions across the entire thing. But we'll do that for right now, just to sort of get out of jail here. But I think again, this is the type of thing where the more permissions you give this thing, the more interesting it becomes. And because it's happening with the default namespace, the default service account, that gets applied to both the playground and the controller. And the playground may not need all those permissions, but everything that's launched by default here is going to get those permissions. Okay, we had to remove the old installation guide because it relied on host port in the Docker registry proxy, which seems to no longer work. Okay, so yeah, host port doesn't work with CNI. I never used the Docker registry proxy for a while. I think, again, like the proxy stuff is like, the registry stuff is really confusing. I think having a sort of a guide for running a local registry or running a local registry proxy might be an interesting thing for me to do a little bit of research on. And I do know that, like, how do I actually get this thing hooked up to Amazon, or how do I get this thing hooked up to GCR is something that folks care about also. It's going to be a dangerous show if I do that, because I'm going to be copying and pasting credentials everywhere. Right, I got to be careful around that stuff. Okay, so we'll just go through, we'll do the cluster admin stuff. So kube control, apply -f. Okay, so Monty's saying that he uses the Docker and Docker method of actually doing this. And I think that's an interesting container to be able to do this. But it turns out that when you give a container permission to run Docker and Docker, you're still contained, but now like you have to give it enough permission on the thing that you throw out a lot of the security guarantees. And so it's not quite the same sort of end run around Kubernetes that the sort of mounting the Docker daemon port is, or the Docker daemon socket is, but it's still pretty scary from a security point of view to actually give the permissions to do Docker and Docker. It turns out just the Linux syscalls are not good enough to do. My understanding is that, and I haven't dug deep in this, but they're not good enough to do Docker and Docker in a safe way. So there is no sort of nested virtualization type of thing going on there. That might be another approach to take here if you want to do building, is that there are systems for running virtual machines inside of a container if you're on infrastructure that supports virtualization or nested virtualization. You might be able to run something like QEMU. Or KVM inside of a container, and then run your builder inside of that. So that's a very heavyweight Docker and Docker. Okay, so we did the cluster role binding here. Yeah, so there's a sharing a local registry with Minikube posts. That's a good guide. Yeah, it's pretty arcane though. You're right, Josh. I mean, there's a lot of sort of voodoo that goes on there that's worth digging into. All right, different episode though. We're not going to do that this episode. Okay, so now we gave the default service account admin. We're going to go through and we're going to do the controller here, and then we're going to do the playground. All right, and now what this thing we can do. So this is running in the default namespace. So one of the other things that I love to see as these things happen is support for putting this in a different namespace, or being a namespace aware. And I think, one of the things that I'm looking for in the difference between sort of something that is, more prototype type code is, let's not worry about namespace, let's not worry about security, as you start looking at how is this going to work inside of a inside of a production cluster that perhaps has some level of multi-tenancies, start thinking about namespaces makes a ton of sense. So this thing is okay. So now we have both the playground and the controller up and running. And then it says browse to Minikube IP. We can't do that, but I have a solution. Oh, so Yaron says the namespace is configurable, so that's good too. I have a solution there. So, okay. So you see something like this, and it works fine with Minikube because Minikube is sort of sitting on your local network, and and it's using a node port to be able to get to this stuff. So there's three ways that you can actually go ahead and work around this if you're not running Minikube. So the first thing is that you can create like an SSH tunnel to the master or to one of the nodes in your cluster and then hit it on that port. And so that's essentially using the node portness. The second thing you can do is you can use kube control port forward. When you do kube control port forward, unfortunately, it only knows how to talk to pods. And so you'd have to go through and find the pod and do it to that thing directly. And then if you're playing around with this stuff and say upgrading or pushing new versions, every time you do that, you have to go through and restart your tunnel because your pod name will change because as we do a deployment, obviously we throw away pods and launch replacement pods and they come up with different names. The third thing you can do is kube control proxy. Kube control proxy is essentially an HTTP only type of thing. It goes through the API server. It knows how to talk to services, but unfortunately it's HTTP only. And because it sort of exists at this deep URL, it does some really funky things where it actually tries to go through and rewrite the content that is returned. So it's actually kind of an invasive thing that gives me the heebie-jeebies. It works well enough for the Kubernetes console, which is I think what people use kube control proxy for mostly. But for reaching other services, you'll see people do it sometimes. For me, I'm not so sure. So I'm going to do the SSH tunnel type of thing. And what I have here is, let me find it, is if I do code TGIK, or actually, I have it in this other window here. Okay, so I have this thing called run tunnel, cat run tunnel. And I'll edit this. And what this is I have some environment variables that I set up. So the way that our AWS thing works is that we have a Bastion server that's on a public subnet, and then we have a private subnet that actually has the Kubernetes cluster. And so when you SSH into the master, you have to use this proxy command thing to say, well, first SSH to the Bastion, do a netcat to the eventual destination, and then do SSH to there. So this is sort of the preferred way to SSH through the Bastion. There's another command you can use that doesn't require netcat, but it requires a certain version of SSH, and I always forget what it is, so this is what we're going to do. All right, so we're going to map the port number that we had there. What did we have? Was it 3900? It was 32050. Okay. And is that it did specify the node port, not just that it wanted a node port. It was very specific about the node port. Where did it go? I did Control C here. Let's do Control C or Command C. Why is this thing not? That's crazy. Why can I not copy and paste here? Something weird is going on. 32050. Can I copy and paste from here? No, that's not working there either. Is something up with my VS Code? I'm gonna quit VS Code and relaunch it here. Sorry about that. Sometimes when stuff like that happens, I'm just like, what's going on here? Now it's working. All right, so something got whacked with VS Code. All right, so this is essentially this SSH command, and I'm going to run that tunnel there. Now I'm SSH'd into the master, but along the way I created that tunnel, and so now I should be able to do localhost 32050, and oh, look at that! Now we can actually play with the thing. That's exciting. All right, so that's actually a really easy startup. That's not insane. There's still the question of doing the building and stuff like that and pushing to a registry, but let's go ahead and try there. All right, so now deploy a function with Nuclio CLI, or we can do the playground. Let's choose one of the built-in examples. And oh wow, there's a lot here. There's a lot of documentation, which is actually really, really interesting. So let's go through and we'll go to the playground here, and we'll select a function. So let's do, I mean, we like Go, and I think Go definitely shows some of the sort of speed stuff that happens. So let's do this regex scan. So here's a little function here. Okay, so this fascinating thing here is what we're going to see is package main, but there is no main. And so, so obviously Nuclio, when it actually sort of, it's going to do the building of the binaries for you, and you don't give it a whole program, you essentially just give it a handler. And the handler is specific to Nuclio. So this is not a generic HTTP handler. This is a more Nuclio specific stuff. And so then there's a Nuclio SDK here. So this starts to starts activating some of the using Go plugins. Okay, so which are you doing the Linux Go plugins you're on, or are you doing like the HashiCorp sort of plugin stuff where it does sort of a local gRPC type of thing? When you say Go plugins, are you doing like the shared library stuff? There's all sorts of approaches there. But anyway, so this thing is going through, and let's see, you're giving it, you have an event, and the event has a path and a size. Okay, so that's sort of thing coming in. And then we have a bunch of regex filters like SSN and credit cards. Okay, so this is looking for stuff that looks like it's bad form. The built-in Golang plugins. So the Linux plugins. Okay, so this is the shared library stuff. So Golang plugin shared library, that stuff. Is it like, because I think there's the HashiCorp stuff, which is what we're using for Arc, which is our backup and recovery stuff. But I guess there's, is it this? The build mode plugin, okay. Then so yeah, so this is the shared library stuff. So this only works on Linux, which is interesting, which is fine because it's like this is all Docker based, and so Linux is where it's at. This stuff is still like I don't think that there's that many folks using this yet. So that's really interesting that you're using that. Okay, so this gets built into a plugin, and so you're not actually manipulating the code, you're actually hosting this in as a shared library and then looking for this stuff. So that's actually really, really interesting. And so, okay, so yeah, so you're avoiding the RPC serialization, deserialization stuff that you get when you do like the HashiCorp plugin stuff. Yeah. So again, I think this is a theme, and so Yaron's talking in the chat here, whereas a lot of the Nuclio stuff is really built around high throughput, being able to handle a lot of events. And so in some ways, I think there's an analogy here between sort of the different ways that people write serverless code and functions that plug into sort of the hosting environment of the serverless platform. I think there's an analogy to things like CGI, WSCGI, like, Apache, modules and plugins and stuff like that. And that sort of whole process that we went through as people chase better and better performance on the web, right? So we started with CGI where it's like every request like created a new process. And so it ended up being very slow. And then you move to like sort of like a protocol where it's like, well, you launch a process and you reuse that process again and again, but you're only doing one thing at a time to that. And then you move to something that's more like Apache, plugins like mod PHP type thing, and in those cases the language runtime is really integrated in a sort of high throughput way. And so I think one of the things that I'm getting the hint of is that Nuclio went down that path of trying to really optimize for high throughput by taking a unique advantage of the languages that you're dealing with. Yeah, okay, so Yarov says that for Python, the PyPy DLL is built into the Nuclio Go process, so that's interesting using PyPy there. And so like, yeah, the focus is really being able to reuse runtimes and put a lot of stuff through that. Relatively straightforward with Go, because Go is kind of built to do a bunch of that stuff from the start, but adapting other languages ends up being interesting. And then PyPy functions are fine. Yeah, it's fascinating. So folks know what PyPy is? PyPy. So PyPy is Python written in Python. It kind of bakes my noodle. But what's fascinating is that a lot of times it ends up being faster than regular old Python, which is really, really interesting. So yeah, so it looks like the Python stuff is using PyPy. Okay, so we can go through here. This thing is essentially looking at a document coming in that's part of the event coming in itself. What exactly turns into an event is an interesting thing we can explore. It's going to go through, it's going to look for some regex that look like they might be bad things like credit card numbers or social security numbers. If it sees those, then it's going to write out a warning and then return a document that actually says that stuff. Otherwise, it's just going to return passed. And so what I'm seeing from here is that we have the event, which is an abstraction for HTTP calls, different types of things that might trigger something. There's a context here. I wonder if that's a Golang context. I'm assuming that it sort of embeds a Golang context. But in that comes things like the logger, and then the results of the function are just returned as text. And I assume maybe in the event or somehow you can actually set things like MIME types if you're doing HTTP. So check the triggers tag for event source options. Okay, we'll definitely get to that. And then I'm not sure, like this one, like sometimes it returns JSON and sometimes it returns a string. I'm not sure that's the right way to go, but I think it's just a sample. So let's go, we're gonna hit deploy on this. And what's this gonna do? So this is gonna build an image, pulling the base image here. Okay, results can be structures or unstructured. But either way, so this Marshall, this is going to be a string and this is going to be a string. So you could do that. And I think it's just like the protocol, if you're doing this, is sort of like a RESTful sort of, or even JSON RPC type of thing. Sometimes the results are going to be a regular old string. Sometimes they'll be JSON. So David says, might be a silly question, but how is the document data received? Like what can be the source? So I think that's not a silly question at all, David. And I think that's what Yarn was saying is that you can have triggers here, and you can do HTTP, RabbitMQ, Kafka, Kinesis, Nats, and then V3IO, I believe, is a Iguazio specific protocol there. But I think if you have HTTP, all right, so now we can start setting some interesting stuff up here. But we'll get to that. Let's see if we can get this thing deployed. So it's still pulling that base image. We'll give that a second. I assume that it's not the type of thing you'll have to pull that many times. Okay, Parthaban says deploy failed with Docker socket connection failure in my case. What were you running with, Parthaban? It's kind of hard to debug, sort of. All right, so what do we got? Failed to deploy, failed to push processor image. So the problem here is that we tried to do a push, and we got, oh, and this is assuming that you're running a local registry on port 5000. Let's see if there's a way for me to configure build base image, runtime attributes, namespace handler. Okay, so deploy, the deploy failed. So Yaron, do you know, is there a way for me to actually configure to use the Docker Hub here? Is this configuration for, this is a build base image code. This is really configuring the playground itself in terms of what it wants to use. Let's see if we can find the Nuclio Playground. So, yeah. So this includes the builder. Aaron says you'll need to follow the GKE guide to configure the playground. So what does it have us do? Okay, so here's the... All right, here we're doing all sorts of servers account secret stuff. All right, so create a config map, and then I assume that we have to... All right, so let's go through this a little bit here. So... registry, okay, from literal, registry URL equals blah. And then And then we have Nuclio Docker keys. So this is a secret generic. So, okay, so this is fast. Okay. JSON key equals this. All right, so this is one of those things that actually gets a little bit tricky here around doing this stuff. Let's see, what can we do here to get past this? I could go through and I could configure a GCR registry here, and we can just use that. We'll be hitting that from Amazon. That's not totally crazy. All right, I'm going to go ahead and do that. We're gonna go a little bit off script here. So I have let's go through and I'll, because I think it's useful for folks to see this. G-Cloud configurations, config, activate, TGI. I wasn't planning on doing this, but config configurations. God, this is. There we go. Okay. So your Docker C with not GKE. Yeah, we're not using GKE either, but I think we can use the GCS. So we can use GCR, which is the Google Container Registry, and we can create credentials from that. We can install that into the Amazon cluster, and we should be good to go. So the first thing I'm going to go here is I'm going to go here, and I'm going to go source setup kubeconfig. So we actually have all this stuff. Okay, and now I'm just going to do this. I have service account list. What do we have? So we have the. Oh, this was stuff that we did in the last episode that's left over. We're going to create, and I can do this, and then I want to name my IAM account. I'm going to use the GCE default service account. We could create a new Google service account. Okay, so this is super confusing because Kubernetes has an idea of service account and GCP has an idea of service account, and these things are just like totally different. There's a bunch of work ongoing from the GKE team to try and create ways to create equivalency when you're running on GKE to have Kubernetes service accounts be able to be mapped to GCE or GCS service accounts. But like this is a different type of service account just that is specific to Google here. All right, so we created a key as blah, blah, blah. So there's the thing that we need right there for that thing. Okay, so we created that. And then I'm going to go through and I'm going to create this thing. I'm just copy and pasting some stuff here. So this created a secret with the information that I did with this sort of like keys create for the service account. So we're there. So Aaron says, technically we can use any private registry. It's the same dance with all of them. Create a secret with creds. Yeah, so I think that's fascinating, Aaron. I think the interesting thing is that like what are the secrets and what are the formats and sort of how do you find the thing, I think would be useful. And then also just some concrete stuff with like the Docker Hub, because I think that's going to be a lot of folks go to. So actually having documentation about how do I configure the playground with the Docker Hub might make sense. And then finally, if in the playground itself, if you had UI such that you could say, here's my registry, configure it, it could then go in and configure itself too. And then we're going to go through and create a config map, and this config map will only have one thing, which is the registry URL to use. And then we go through and we're going to look at, there's one called GKE. We're going to do diff Playground and GKE Playground. So what did it change? So it added an ingress that you could get to the playground, which is dangerous, by the way, because now you're essentially opening this stuff up to the world from the get-go. And then it's doing the Docker keys and an environment variable for that, and then mapping that in as a... All right, so let's go through, and we're going to go to VS Code, GKE, or... GKE Playground.yaml. Yeah. I'm just throwing suggestions at you. I think this has been pretty well documented so far, so I'm not gonna be too hard on you. All right. So what we need here is we need the, and then I'm gonna go through and I'm gonna edit the playground here. So we have two playgrounds. We have the GKE playground and the regular playground, and so I'm not going to just apply the GKE one blindly because it does stuff like ingresses and stuff like that I don't want to open this stuff to the world. So we have a volume mount here. And then this ends up being the whole end stanza is new. Wait, what did... Oh, I didn't get the... And this is here to volume mounts, and then we need the other volume, which is this thing from the secret. So yeah, okay. So we're mounting the keys in Etsy. So those are called Docker keys. I read only true. We're mounting that in. That's coming from the secret, and then we're also using we're using a config map to be able to get the registry URL in there. And so this is coming in as an environment variable versus say like a command line flag. And then there was something else was HTTP. Oh, the service. Okay, the name was changed for the service, and then there was an ingress, and we're not going to do the ingress. Okay. So now let's go through and cube control apply -f playground.yaml. Now this should do a new deployment. And so it's doing the rolling update here to be able to get there. And let's go through and we'll do a refresh on this. We're going to pick the regex scan one again. We're going to hit deploy. And it's going to pull the base image because it probably got deployed to a different node, and so it has to pick a different base image there. Hopefully you are following around that long there, because we've now mixed two different clouds here, because I'm running on Amazon, but we're using the Google registry just because those were the copy and paste instructions that I had. And it turns out that using the Amazon registry, ECR, outside of Amazon is actually kind of tough. It turns out it's one of those things where it works well if you're running on cluster, where you can like use the credentials that are sort of built into the Amazon stuff, but it's difficult to get long-term credentials for ECR. It's something that's actually easier with GCR than it is with ECR. And all right, so this thing's still pulling the base image here. So yeah, I think definitely going through some of the nitty-gritty of around sort of like how to talk to registries and how to use private registries might be a good TGIK, because that stuff ain't easy. Okay, so one of the things that I think is interesting here is to call out, and I think there's a difference of approach between different serverless platforms, is that Nuclio is obviously building new containers when you deploy a function, right? And so, and I think if we look at some other systems, they have a standard image and they inject the program in the image at runtime. And so it's like there's really two different approaches. Okay, so we still got the error. Please enable container. Oh, geez. Okay, I'm gonna go just to me for a second because I don't want to accidentally show stuff on the screen, and I'll explain. Let me get to the right thing, and then I'll explain what that error means, because in case everybody else has it, and some of this is just BS from Google. Okay, so here's the thing. So this is a project that I created for TGIK last week, and it turns out that Google does some just-in-time provisioning for some stuff. Like the first time, like before, you can create a project in Google, which is essentially kind of like an account in Amazon. You can create a project in Google, and until you actually click on the Compute Engine tab here, you can't actually launch Compute Engine stuff, right? So it does some like sort of, provisioning the project is not the same as provisioning for services that are sort of associated with that project. And it's probably the same thing with with the container registry stuff. So if I go through here and if I just click on this, what you'll see is like, can I go through, and if I look at images, maybe it's good now. So let's see, that may have happened fast enough. So, because it was saying, please enable it because you have to go to, oh, it says project equals Nuclio GKE. Oh, why is it looking for that project? Is that hard-coded in the instructions that I used? Did I copy and paste some stuff? Oh, yeah, there it is. There it is. That was my bad there. I didn't read this thing closely enough. All right, so let's go through and we'll fix that. So there we go. We're going to recreate. No, that's not what I was looking for. That's the wrong one. This is the one I was looking for. So this config map I screwed up. Okay, so we're going to do cube control edit config map. That's all me. Nuclio registry. Is that the thing? Yeah. And so if we pull this up, what you'll see here is data, registry URL, Nuclio GKE. This has to be TGI Kubernetes is the thing that we're actually going after there. Oh, this is going to cause other problems too. All right, so so let's go ahead and do this. I think we're going to hit other problems too. So let's just do this as the next thing there. And so now I have that config map. Now what that's going to actually cause is because this is an environment variable, I need to go through and cause a redeploy. And so there's and so it turns out because I changed the config map, actually causing a redeploy is actually kind of interesting. I want to. So one way to do this, I can do let's go in and we can look at the playground that we have here. And I don't really want to change anything because this is pulling stuff in with an environment variable. So what you can do is when you look at your deployment here, inside the spec, inside the template, you can go through and like do and you can do fake deploy. And this is enough to essentially be a no-op, sort of change stuff and cause the thing to redeploy. Apply. So we'll just go ahead and we'll reapply. Oh, now it's mad. What did I do? Cannot convert. Oh, this has to be a string. There we go. All right, so this will go through and actually do the redeploy. All right, so now we are back up and running. Okay, and David said maybe the service account is not enabled in the admin part of the cloud. No, I think the problem is that I was specifying the wrong registry because I was just blindly copying and pasting some stuff. So we're going to go through and we're going to try this stuff again. Regexpand, deploying function. It says deploy started successfully. It's going to, I had 3 nodes, and so we hit the 3rd node now, so it's going to have to pull the base image yet again, so that takes a while. It must be a pretty big base image. Let's go through and this is on my master. If I go through and I look at this, I can or just if we just SSH into that, let's see, is that going to work? Okay. Let's see, what do we got here? So we got a bunch of stuff. Why is weave? Oh, that's because we have that stuff preloaded for spin up time on our images here. But okay, I don't see the image here. After reviewing a few service platforms, I can't see the value in dealing with source code. Container images provide a better contract. So, I mean, that's Kelsey's opinion. I think that what we're seeing here is that once you add container images into it, there's this whole method of how do you manage those container images. You have to build them, which is a problem because you have to have a way to build them. And you have to go through and find a way to deploy and download them in a safe way. There's a garbage collection thing. If you're rolling over a bunch of these things, you have to garbage collect them. And so I think like like when people are using Kubernetes at its core, there is this stumbling block around building and maintaining container images, and that is both in terms of how do I specify a Docker file and run that process, but then the other thing is like, how do I manage a registry and my connection to a registry and protecting that information? And so I think, a serverless platform like this that uses images like solves half the problem because you're not worried about Docker files anymore. You're not worried about the layout of your image, but we're still importing a bunch of the problems with managing container images outside of the serverless system itself, which is, so I picked the one node that this thing wasn't on. So let me go through. So yeah, so I think there's still trade-offs here on this stuff. Nuclio Playground. Okay, so we had to download a 700 megabyte image as we're doing this. So the base image for Golang is 700 megabytes. So this means that we're going to create pretty hefty images as we do stuff. So you really want to have a local registry when you're using Nuclio, right? Because if you're constantly uploading and downloading these things, well, I guess the base image actually will be shared, and so it'll be relatively straightforward after that. But like definitely that first time for downloading is a hit. Okay, so now we go ahead and we did that, and it says function deploy complete. So the function is only 20 megs. That's the delta after you build the stuff on top of that base image. But if you upgrade the base image, which is something that's going to happen over time, that's definitely going to be the image. Okay, the image is just for the builder, and it builds a minimal image. Okay, is that what you're saying? Yes. Okay, so here's the image that we ended up building. Okay, and that's 40 megabytes. Okay, so that still seems reasonable. Okay. Oh, and it still created. Okay, that's the one that it created. Okay, because I'm on the wrong node. Okay, so now we're up and running. Kube control get pods, and I see. All right, so this is the next problem that I knew we were going to hit. Is that we deployed this thing. And this thing said function deploy complete, but the thing's not actually running, and it's image pull back off. Because I was using GCR, I was using it through a private, GCR registries are private by default. And so I was able to create the image, but now I'm not able to pull the image, right? So I have two choices here. So the first choice is that I could give my cluster permission to be able to pull that image from that private registry. The second option that I could do is I could make that registry public so that anybody can read it. What do you all think? Should I make the registry public, or should I teach my cluster how to speak to a private registry? Which one do you think we should do to actually solve this? I'm waiting to look at the chat. We'll see what folks say. Because I could go either way, and I think it's arcane configuration stuff any way you slice it. Yeah, the image pull secret. Yes, exactly. Keep private. You guys want to see it the private? Okay, we'll do it the private way. Well, I mean, there's reasons why you want to do it the public way if you actually want to like make it public. Oh, Chris says like because we're lazy. No, we're not lazy, Chris. We do things right. We don't take shortcuts at Heptio. Image pull secrets. There we go. Pulling an image from a private registry. So we're going to do that. So there's Docker login. There's create secrets. We have this thing here. These things are all sort of like Docker, GCE. I don't know the things I need to do for GCE. I know and this was early on in Heptio's world, we actually created a tutorial around this stuff. And I know that Jennifer was going to try and get that into the public docs. I don't know if that actually made it there. There we go. Pull from private registries with Kubernetes. And we're going to do GCR here. And let me make this a little bit bigger so that you all can see it. So here's how you create the service account, and you add the sort of the right bindings for this. It turns out that we cheated before because we were reusing the GCE default service account, and the default service account for GCE already has a lot of these permissions. So we can go ahead and we're going to reuse that JSON key that we already had before. And now what we're going to actually do is we're going to copy and paste this, and I'll put this in the keynotes also. So we want to have registry secret equals, and we're going to call this thing GCR secret. Okay, and then so the Docker server, the username is JSON key, and then we actually have that there's the JSON file there. So actually, let's copy and paste this, and we'll create a little script for this. Actually, we'll do code setup GCR secret dot. All right, we'll do that, and we're going to copy this stuff here. And this secret name, we're going to call this thing, what do we call it? GCR secret. So the question is, shouldn't Nuclio reuse the Docker key in the service deployment? Well, the way that we set up the secrets for the playground was using secrets that were of a generic type where they're just for the playground. To set it up for other stuff, you have to do some other stuff. It could have gone through and referenced if we had done the secret the right way. It could have been able, if it was in the same format, it could have used that when it's launching the pods to say, hey, use the same secret. So I already have a secret that allows to push the image, but that secret is not in the same schema that you need for the image pull secret. So I think there's enough of a difference there that we kind of have to go through this stuff again. So things like the server here is GCRIO, because that's the registry endpoint that you're talking to, but the registry that you're talking to is something different because that's essentially the prefix for the thing. The names here can kind of get confusing for the types of things that we're talking about. Docker email, I think the Docker email doesn't matter anymore. Nobody pays attention. And then this is the contents of that file, Docker password, and so this, what do we call it? We called it this. So we're going to go ahead and do that. Chmod plus x set GCR secret, set up GCR secret. Oh, it says flag Docker password is required. What did I do wrong? Oh, cat. There we go. Well, if the playground built the service, it knows what creds the registry needs, or am I wrong? Yeah, I think it would be, like, it has the creds, but for it to start sort of like taking those creds and republish them in the rest of the cluster, that would still be a little bit freaky, right? Because you don't want people to be too fast and loose for those. So there's definitely a usability stumble here because of the requirement for a registry with the playground, but it's definitely one that you have to do it in a way that you're careful around security then too. You guys caught the missed cat. I caught it too. The delay. I figure if I can catch my mistakes before you guys show up in the chat, with the 15, 30-second delay, I'm doing pretty well. So there we go. Okay. So we got the secret created, and now if we look at this thing here, now the question is, how do you actually go ahead and use it? So one of the things that you can do here is you can patch this thing into the service account thing. So you can say anything that's using the service account is then going to use this image pull secret also. So that's one way to do it. The other way is that when you define the pod template, whether it's through a deployment replica set or directly or what have you, there's a field on there for which image pull secret you want to use. And then this gets passed on and sort of configured into the container runtime. We'll go through and we'll do this through the service account because it's not clear if Nuclio, when it launches pods, knows how to actually plumb through the secret that you want to use. But we're going to do a little bit different. We're going to do kube control edit, service account default. And so here we have this, and here's the default service account. And then we're going to add image pull secrets. Oh, this doesn't have a spec and status. Service account doesn't. Oh, I thought it did, but. And then we're going to do name. Is it yeah, it's an array. And okay, I'll line up the thing with the stuff before. Name, and then what did we call this? We called this, I have GCR secret. I have the memory of a chipmunk.
Sorry, could you say that again?
No, Siri, I'm not going to say it again. Did you guys hear I accidentally hit Siri over here? Okay, so GCR secret. So that's the secret that that thing's going to pull. We can go ahead and do that. It accepted that. Now, cube control get pods. Let's just go ahead and kill this pod. And I believe it'll create a new pod, and that will, oh, it says container creating, so I think we're able to do the pull now. Oh, and we're running. Okay, so here we are. We got the thing up and running. With all my yabbering, it probably took us about an hour to do this stuff. But, okay, so now we got the playground. This thing is up and running. So here's a little digression that I'm going to go through right now. So you can see here that as far as Nuclio is concerned, the deploy is complete. I'm able to actually do it. So what this means is that it told Kubernetes to deploy something. Kubernetes says, yes, I'm on it, boss. Now, the difference is that, and this is just part of the model for how Kubernetes works, is that Kubernetes will accept instructions and say, yes, okay, I got it. That doesn't mean that it was successfully able to complete them. So this was a great example. It says, yes, I'll try and make this thing work, but then it hit problems. And those problems don't show up when you submit the original deployment. The deployment looks well formed. It's just, it turns out that Kubernetes hits an issue later on. And this is a general problem. I know I've talked about this before, where in systems like Kubernetes, it's really a goal-seeking sort of like, you declare what you want to have happen, and then Kubernetes tries to make it happen. And if things diverge, either initially or after a certain amount of time, if something breaks, it'll try and correct things and actually sort of bring it back into its idealized view of what it wants the world to be. That's really useful from a sort of self-healing point of view, from like, I want to create some code. I mean, I want to like create some infrastructure, and if something changes, I want to fix it, right? That's a very stable pattern for this thing to be in, and that's the controller pattern that's used everywhere with Kubernetes. The big problem with that, and the thing why, and I think what kind of bit us here, is that there's no idea for it's done, right? So like if I say, hey, Kubernetes, make sure this pod is running, let's say that the pod comes up, it runs for like 50 seconds, and then it crashes, right? Do we declare victory after the first run, or do we declare victory after it's been stable for a while? Like, you know, if I say, yes, it's up and running, but then by the time I return it to the user, the thing crashed again, then you're like, but wait, it's not running. And so I think what you really need to do is be much more clear about when you consider things are done, and think about sort of reflecting status back versus thinking about saying, yes, it's done. So I think an interesting thing to look at here, and this is just a playground, but you know, can I actually say what are the functions and what are the status of those functions, which is a different thing for saying, hey, this thing is actually totally up and working. And so Aaron says, yes, the plan is to update the function CRD status with the actual deployment status based on the health check. Yeah, and that's exactly the type of thing that you want to do, because it's really about reflecting conditions and current status than declaring victory like something like this. And I think we saw with that image pull issue where that actually turns into. Okay, so we are like way in the weeds here, but let's go back to, so we went through and we used the playground to deploy things, and then I want to invoke it. And so I can just go through and I can do a post to this thing, I guess. Content type JSON. This is a test. And let's sort of send it. And what happens? And it says passed. And I can do 1, 2, 3, 3, 4, 5, 8, 5, 8. And, oh, that contains a social security number, so it returns a body. Oh, now this is fascinating here. Oh, I see. So this one says it passed, and then the status code is 200 OK. This one says, I see. So this is, okay. Oh, this is, okay. So this is the, okay, function invocation response. Okay, so this is the response for the first one. And then the warning shows up here also. And then this is the response for the second one. So it was both a 200 OK. Here's the headers, and then we're up and running. It says, no, you're a social security number. Or if I do, you know, but if I do something like that, it says like everything's good. All right, awesome. Yeah, that's very, very cool. Okay, and so Yaron says you can see the function status via CLI. So I think, yeah, so I want to definitely play with the CLI, and I want to look to see how this stuff works. So let's go ahead and get the CLI and play with that a little bit, because the playground's just that, a playground. And I think, and I'm glad that it's called a playground, because I think what we've seen before is that this is great for really getting a feel for a system, but like right now, like this is not necessarily something that's appropriate for a production system, because not just because of the builder stuff, but also there's no authentication for this thing. It all works within the default namespace, so there's no idea of sort of like, hey, am I the user dealing with this particular web interface? Do I have permission to actually deploy in the context that the thing is actually talking about? So yeah, so I think this, it would be really dangerous to deploy this playground someplace that was publicly accessible. And so we saw in one of the previous, I'm not going to name names because it was a horror show, but like if we saw in one of the previous serverless episodes, I went through similar instructions, and there was a playground type interface that was exposed to the internet. I happened to do it on an easy to type URL, and somebody went through and started submitting malicious jobs while I was doing the TGIK. And so the GKE instructions here, when we were looking at those, opens up an ingress to the playground by default, which is like, that's essentially giving somebody root on your cluster by default. And so Yaron says that you can also create ingress rules based on the function for triggers, and that seems totally appropriate, right? Because that's user code that's coming through. Now, one of the other security problems that we see with Nuclio so far is the way that Nuclio worked with RBAC was to essentially give the default service account root on the cluster. But what you'll actually see here is that the workloads themselves are also running as that default service account. So I essentially, within this little function here that is just checking a string for social security numbers, if I called some other Golang code, I could actually go through and start talking to the Kubernetes API server directly from within this code. And so that means that if somebody were to break out of my Go code, I mean, Go is safe, but it's still possible, then you're essentially like giving them root on your cluster. And so one of the big things about RBAC is not only to protect one user from another, but also to be able to run your workloads in a sort of least privileged type of mode. And what we're seeing here is that we're sort of throwing away some of those RBAC advantages with the default configuration here. So let's see. So the function also creates ingress rule based on the HP trigger config. Yeah. So that I want to play with that because that's really cool, and I want to see if that works with Contour, which is like totally going off script. And then Marky says it's slightly like Apache Zeppelin. I haven't played with Apache Zeppelin, so I don't know what to tell you there. But okay, so let's go through, and I definitely want to have a chance to look at the Nuclio command line. Let's see. Deploy a function. Oh, that's the GKE instructions. Okay, so new control for my thing. So here we have Darwin. All right, so this quick plug here for y'all. Like Brew makes this stuff so much easier, and there's this utility that we started using for KSonic called Go Releaser. If you go to goreleaser.com, which makes it super easy to sort of release a command line tool in Go and like do things like create a Docker container around it and create a brew config and stuff like that. So that's actually makes it really easy to sort of manage releases for things like this. So something you might want to check out there. So now we can see, if I go container registry as I go back through this, now we can see we have the Nuclio. There's that thing there. Okay, so I'm sorry, where was I? I was trying to download this thing. Okay, so I'll download the Darwin one. Is that going to get me? Oh, it's a redirect. Dash hello. And I assume this is the binary itself. Okay. And so let me read some of the things. Okay. Ferdinand says, late again to the party. Toward the end, could you compare contrast with OpenFast since you have gone through both? Call it in your FOSS segment. Yeah, I want to. I honestly, I think, I don't want to do. It's hard for me to really do it justice. I can talk about sort of what I'm seeing here. And these things are moving targets too. I know that the OpenFast stuff those folks have been working on moving things forward. So I don't want to be too I don't want to like do a comparison based on old data. Okay, so Yarn says the function runs in a pod without root privileges. That's true, but it still has access to the network in the context of that network, right? And so so there's the question of does it have access to the file system inside of that thing to be able to read the service account token that gets written to disk, as there's new ways of communicating in and out. I think that's one of those questions there. I would feel better if that service account token were in no way, shape, or form available to the function by default. And I would also think it would be interesting if you could actually say, I want to run this function with this other service account, because then you can actually have serverless things that actually are used to actually drive Kubernetes itself. I think one of the experiences, if you've ever used Lambda in Anger, is that like half of your CloudFormation template is setting up IAM permissions, and it's a total pain in the butt and it's really fiddly, but that also is part of the power, right? So because Lambda can call into all the services across all of Amazon, that's part of the power, but you have to be able to call into those things in a responsible way. And to do that, you really need a system like IAM that you can actually rely on. We don't have the identity system that I think we need to have in Kubernetes yet. I think there's a lot of work going on that, but at least when you're talking to the Kubernetes API, I think it would be interesting to make sure that this is plumbed in a useful way. Okay, so we can do kube control get functions. So because we have a CRD for this, we have that thing called regexpan. And here what you can see is this thing. Let's see, we have a build. It has a temp path. I assume that like this was local to the builder. But I think the interesting thing here is that we actually just have the image here that we're dealing with. Okay, so interesting thing here is that this thing actually picks latest by default. I don't know if maybe that's just an artifact of the playground or whatnot. But another thing that I would look for in a platform like this is actually being cognizant of versions, and as you're doing rollouts and rollbacks and stuff like that. Functions have versions. If you're using those with images, you want to make sure that you line up your this idea of versions of your function with the images that are actually sitting. Okay, so Yaron says we have versioning. Okay, so this is just an artifact of the playground where it just does the latest thing. And we have things like version -1 here. Okay, so I have that thing. It's downloaded. I want to move to, we're going to do that. All right, look at that. We have some stuff going on there. Let's see if we can do get function. All right, so we have, there we go. So this is another sort of thing in the pattern that we have here. So that's great. And so you said this works via CRDs. I like the fact that it works via CRD. That's really interesting. Once you work via CRDs, that actually starts playing with the permission system, because you can assume that if somebody has permissions to write that CRD, that's something that like the admin can RBAC, they can control. And you can say, well, if you do a CRD in a namespace, then you get to actually work, we'll launch pods in that namespace, and you actually share context, and that namespace ends up being the boundary there. So we got that going on, which is great. And then we have an example here. Okay, so deploy we're going to do a hello world there. Let's see. Oh, let's go. Okay, we're going to go back. Okay, I'm going to copy this thing to my local bin. Oh, this is the wrong thing. New control. New cuddle. On Hell, it's a little bit off topic, but a TGIK to go deep on CRDs. Yeah, I think that would be a good thing. I think, CRDs are relatively simple in concept. I think the interesting thing is how you program them. I think if you look at the metacontroller one, that actually starts giving you some of the data about programming them. You can also look back at the series that I did on a controller. It didn't use a CRD, but those things sort of pair together. Andy Goldstein, who works for us at Heptio, has also done some really interesting blog posts on how to build, use the Golang code gen to actually deal with CRDs. So that ends up being a really interesting thing too. Okay, so we have new control. Okay, so we got that here. We are looking at hack examples. Examples, Golang. All right, and so hello world. And okay, so we can do new control deploy. What are the parameters that we have here? Oh, there's a lot of stuff here. So let's see what we got going on. So we have deploy -p is the path to the function source code. And so hello world.go. Okay, and then the next thing we have here is the registry that we want to use. Now, does this go locally, or we're going to do, I think that's the registry we want to use. Oh, so there's the registry that you deploy to, and then the registry that you actually load from, because the run registry, okay, interesting. Let's see what this does. Oh, I'm not even running Docker. I don't think I have my Docker daemon running. So, okay, so this is doing a local build. So new control would need your login to your GCR repo if you plan to deploy, as the build happens locally rather than on the cluster. Yeah, so we'll do, no, I don't want to do a Docker update right now. Okay, so let's go through, I guess this would be TGI Kubernetes is the thing that we want to do there. And it's probably just going to do a Docker deploy or a Docker push on that. So I think I can do gcloud docker. There's like a, what am I doing here? So this actually does configure Docker. Okay, we can do gcloud docker-a, which essentially caches authorization for your local Docker daemon for gcloud. And because I'm activated on the same project with GCE, GCR, GCP, Google Cloud, then I'm using there, so I'm good to go. And this is short-lived access. These things will last a little bit because it's an OAuth access token if you want the nitty-gritty details. I think there is a way to install a Docker credential helper that will automatically renew as necessary. I don't think I have that installed, but we're good to go here for now. And so this will handle gcr.io. So now I believe if I do this, it'll call Docker, do the build. So, okay, we have to pull down this base image. We have Gigabit here in the Heptio offices in Seattle, and I'm looking at my little resource meter here, and our network is pulling things down at 43 megabytes per second. So I think we're just based on how fast the Docker registry is. So we're waiting to pull this 600 meg thing down again. It seems to be. I can't even see the pretty sort of like things that Docker does. Okay, so now it's building the processor image. Oh, what happened here? Parsing reference, not a valid repository tag. Oh, I did fix this, but then I didn't. Oh, TGI Kubernetes. Okay, let's do that again. All right, so Yaron says, let's look at the triggers in the UI while this is loading. I think we got it going. So. Oh, invalid gcr.io. Isn't that it? TGI Kubernetes. What am I doing wrong here? I do want to gcr.io. Does it not need the Okay, so you don't need the HTTPS there. All right, so this is interesting because it's either like, let's see, the command line flag here was called, if I go up a little bit, oh, I'm going way up, way too far. It was called registry. Okay, not the API. Okay, so function deploy complete. So now we have the hello world also, and I can do. There we go, and we got hello world. So okay, so that's how you do a deploy from the command line. It does a local build, and then it goes ahead and deploys it. I think, you know, I'm assuming that, you know, you can specify there's a whole bunch of things that you can do to fix this stuff up. Whether you just want to publish, you can create a node port for the thing, all that type of thing. So okay, so Yaron says let's look at the triggers here. So that we did a deploy from the command line. We have a bunch of triggers. Let's do an HTTP trigger. Okay, max workers, 3. External port, do I need to specify a port? Do I need to specify a host? Let's do nuclio.tgik.io. Paths, we'll just do that, and does that. Oh, and oh, external port. Why do I need to pick a port? 8. Is this a node port? Like, okay. Let's just say this thing. All right, we now have we have a hello world ingress. Oh, that's fascinating. So the command line created an ingress by default, and it had a bunch of defaults there, and then but the playground didn't. Okay, now we have it there. Okay, and that one's at hello world latest. All right, so option of port versus path, the UI expects it. Fixed in latest. Okay, so would you have to expose service post in order to access the function via the public network? I assume you would. So here, we'll do this like this one was called. We'll call this one regex, and oh. So how do I save this? Do I have to deploy again? Or no? Oh, I have no ingress. So Yaron says I didn't save. I'm not sure. This is enabled false. How do I edit this? I guess I'll, Enabled, select kind HTTP, max workers 3, external port 80, host star, and we'll do paths, regex, and now where do I save? I don't see a save on here. Deploy, okay, I have to redeploy, okay. Deploy started successfully. Oh, so it took the function down. Okay, so it's pulling the base image again. Building the processor image. Oh, and I hit it twice, and so it started doing it twice. I break these things. So okay, plus for save. Wait, I needed to hit plus? Oh, and there's no way to actually go through and edit these things after the fact. Okay. And so let's wait for this thing to settle because we had 2 deploys going on at once. It says build complete. I think I might have broke it. Let's see. All right, so now we have regex scan. It's running. I'm going to hit deploy again. I don't want to. I think we're running close to out of time. It's really interesting stuff. I think I feel like I've still just scratched the surface here of what's going on. Okay, but when I do a deploy, it looks like while it built the image, it actually so I think the playground really is just that, a playground, because I think like there is no like versioning or anything like that supported in the playground. So yeah, folks, I wouldn't read too much into the playground stuff, because I think that's probably not the preferred way to do this stuff. Okay, I don't see the ingress getting created though. I would expect that. So I don't know why the ingress didn't get created here. Get functions. So this thing does have the ingress there. Ingress is HTTP, paths, port. But it somehow it didn't get created. I'm not sure why that is. Yeah, all right, so I'm not sure why that is. Let's go through and delete function. We're going to just delete it. So that should actually, if this follows the model, we should see this thing essentially get undeployed. Yeah, so it's no longer there. I'm going to hit deploy again here, which will go through and build the thing again. So every time you do a deploy, it does another build. All right, so Yaron says that everything is driven via the YAML CRD, which is really interesting. Looks like there's just one CRD. And so I think, there's a tension when you're designing the APIs between having lots of granular objects versus sort of big objects. I think some of the other serverless systems, they'll have like the function, and then they'll have triggers, or be actually a different CRD, and you configure those things separately. And for me, that's really interesting, especially as you start thinking about versions where you can have multiple functions deployed, and then you can have mappings of triggers to those different versions based on that, and you can say maybe upgrade one trigger to a new version versus another. Whereas here it looks like as you push a new thing with a new ingress, it like removes the old thing and then re-adds it. And so there's not a lot of fine-grained control over mapping those triggers to the functions that get called. Okay, so this thing says build complete, and then the result there. And it does have triggers. It does have an ingress trigger specified. Oh, okay, it was in a crash loop. So the playground crashed and restarted. So something's gone wacky with the playground here. And it crashed and it got restarted in place. I don't know why it crashed. That's interesting. What is the thing that actually shows? -P. Go routine. So it crashed. Invalid memory access or nil pointer dereference. So this is honest to goodness crash here when creating the function resources. So I broke something here. I'm not sure what I did. And now the triggers list is empty. So I think this stuff was all in memory, and so when it crashed, it got dumped. Let's try this one more time. We'll hit deploy. So it's executing a Docker build, so we're just waiting for that right now. So it did a push, successfully cleaned up, okay, because this has all been no ops on deploying function, then it crashed again. So something about with that path, something's going. Something is really confusing it. So, all right. Well, I don't think I have time to debug that right now. But let's see if we can do. So this thing is listening on hello world test. So if I do curl http tgik.io/hello world latest. Oh, I have to give it. I didn't map that. So let's do. Foo. Empty reply from server. Okay, so what's probably happening here is, let's see, and this may confuse it. So backend, service port, HTTP, namespace, serverless. So if the UI generates the YAML, but can we edit? So I think yeah, that's a good question for Yaron. It's like it looks like the playground tries to abstract the YAML from you, so you don't see the YAML directly when you're using the playground. It creates sort of an easy experience. So it's probably a useful sort of induction tool for getting people into the platform, but it doesn't look like the playground has been built as sort of a sort of deep debugging tool or a tool to really understand a lot of the core concepts going on beyond sort of that induction type of stuff. So this ingress here, so I think, let's see if we can make this work with Contour, because I think what we need to do here is we probably need to specify that I want, let me look at my example workload here because I always forget the annotation here. No, that's not it. What? Example workload, quard. We have the deployment, we have the service. Oh, there's the ingress. Huh, that should work. Spec rules, HTTP paths, backend, hello world, HTTP path. So this may be an issue with Contour. I can buy that. Oh, now it says food@tgik.io. Oh, hello from Nuclio. Okay, so it worked. Oh, that's awesome. That's super awesome. Okay, so that's, and I didn't do anything. I didn't change anything there when I was like editing this thing. So the ingress out at the gate work. Okay, so that's fascinating. So what we're seeing here is that the ingress that Nuclio sets up is automatically, out of the box works with Contour, which is actually speaks a lot towards the ingress system being interesting and useful. One thing that so let's see, and so I do want to let's see, so Yaron says that working on turning the playground into a full management UI, so that's really useful. Yaron, I would encourage you to take security super seriously there, because I think as this starts being a real piece of how people interact, you want to think about, how do people log into that thing? How do you create an equivalency there between that and what they can do in the cluster? I don't have great answers for you there. You can look at what the Kubernetes UI does. I'm not enamored with it, but it's a way to go. you can also look at maybe making this thing available through kubectl proxy and setting some stuff up there. So the authentication and authorization for a UI that calls through to Kubernetes, like a management UI, there aren't a lot of great patterns there right now, unfortunately. Okay, so the last thing I want to do is I do want to go through and configuring a function. So this is, I think, really interesting. So, and this gets down to sort of, this is the schema of what's really happening under the covers there. Okay, replicas, the number of desired replicas, 0 for auto scaling. You do min and max there of that stuff. I think, and I assume the auto scaling is using horizontal pod auto scaling. So yeah, so if you use JOT tokens, that's interesting. You have to make sure that those JOT tokens actually create an equivalency between what users are actually doing, what access they have naturally to the cluster, and then what you can actually sort of see. So I think it's definitely a tricky thing to work there, and I think the Kubernetes UI might be a good place to look at to start. So data bindings, a list of data resources used by the function. The bindings are currently limited to Guazo Data Platform resources. So I think this is where some interesting stuff that brings in the rest of their platform comes in. And then the list of triggers. So I'm glad to see that triggers is a list, because I've seen, there are platforms, and I'm trying to remember which one, where a function could only have a single trigger. I think that's probably, thinking about these things as a list is interesting. But I'd also like, there's trade-offs to be made between making them completely different versus not. And then there's build, a configuration that's passed to the builder. I'm not clear from going through this tutorial, this whole builder concept. Are there things where you can build on cluster outside of the playground? What does that look like? Because definitely the command line built locally, obviously. But building containers on cluster is a hard problem regardless. So here's the whole thing for the function. So let's see some interesting stuff that goes on here. So we're pulling secrets in from the environment, and they can come from, or environment variables in, and they can come from secret refs. So this mirrors the pod in some ways, where you can actually specify things like secret refs. I wonder if there's config maps also. That would be interesting. These resources and limits, very much like the pod, but I think it binds up the triggers. So one of the things that's interesting to me is that we have max workers here. What is the difference between HTTP workers and replicas? Like this sort of max workers thing is not, what does it say? Yeah, I have no idea what that means. So Enrique says, I'm not sure where the serverless is here, as the pod it creates stays there all the time. Is it the auto scaling is destroyed while not used? Oh, Yarn says, go workers in the process. I see. Okay. So two things there. So it's parallelism within a single container. Okay. So Enrique, and that's a really good question. I mean, you're not going to find everybody to agree on what the heck serverless is. I think the general idea is that you're moving the focus away from managing infrastructure bits towards managing code. So you're moving to the thing being the function, and you're sort of trying to abstract as much of the things that function depends on as possible. That's one definition of this. Scale to zero is definitely a feature of things like Lambda. I think that doing scale to zero within Kubernetes is not something that anybody has done super successfully yet. I believe, I think Fission does scale to zero, if I remember correctly. But the way that it does it is it doesn't integrate at all with the rest of the Kubernetes infrastructure. And so horizontal pod auto scaling doesn't do scale to zero, for example. Let's see, I'll get to that, Yaron. So scale to zero ends up being really, really, really tricky. What you essentially, like if I were going to design a serverless system that does scale to zero, that integrated with Kubernetes, I would do stuff that looked a lot like what Kubeless or Nuclio does, where you essentially create pods and services and you reuse as much of the Kubernetes infrastructure as possible. But what I would do is, for things that have been scaled down to zero, I would actually have a scale trigger pod, right? And so then what I would have do is I would have all the services that were perhaps waiting around, that were scaled to 0, I would have those all directed to a common scale trigger pod. That scale trigger pod, when it sees something come in for a service, it would trigger the scale up, and then it would then go ahead and forward and essentially proxy that thing forward. And so it would essentially hold the request for the time necessary to actually do that scale up. And then what I would do is I would then rewrite the service such that it now, after you do that scale up, it actually bypasses the scale trigger pod and a scale trigger service or whatever, and actually then goes directly to the service that's been scaled up. And then when you scale down, you reparent stuff back to the scale trigger, right? So you essentially have a holding place for stuff. I don't think anybody's built that out. It's kind of complicated. It's a little bit Rube Goldberg, but I think scale to 0 is definitely really interesting. The other way that you could do scale to 0 is that you could build that support directly into the ingress controller itself. That to me, I'm not as excited about that for a couple of reasons. Number one is it assumes that the only way you're going to be accessing this function is via the ingress controller. And so if I do kubectl get service right now here, what we're going to see is I have a service called hello world, right? And I can call this service from another function within the Kubernetes, like maybe another function within Nuclio, or I can call this thing from something that's not running on the serverless platform because it's another microservice. And you can imagine like with something like Istio or service mesh, as you start doing more and more microservice-y types of things, this thing actually ends up being a microservice that's implemented with a function and doesn't go through ingress. And so I would hesitate to build any sort of scale to 0 that has a binding into ingress, because there are going to be ways that you want to call a service that don't go through ingress. Ingress is only ingress from outside the cluster in. And then also, like, it would be a non-standard extension ingress, and so it would be difficult to integrate this with things like, the ingress support, the L7 support for GCE or Azure or Amazon or whatever as these things go. So what I would say is I would actually play games with rewriting this service to go to some sort of like scale to 0 trigger service that would then hold it and then trigger the scaling and then redirect, so that, and you could also use that to measure cold start latencies, because that thing would actually get visibility there. Okay. And so the interesting thing here is max workers here is really interesting. What this is it's the number of the amount of concurrency going on inside of the main function in Go. So the main function in Go is implemented by the Nuclio platform. And these folks were saying earlier that it's using the Go plugin shared library stuff to actually call it under your code. So when you do a build, you build a shared library, this thing links that thing in late. And so this has a certain amount of parallelism. So this means that main will actually keep a worker pool of 4, and that's the amount of concurrency that you'll see. That could be low, that could be high. I mean, it depends on sort of how heavy your workers are. Generally in Go programs, you can get away with like a lot more than that. It's essentially how many concurrent Go routines are you going to actually be having calling this stuff here. It'd be interesting to make that auto scale based on the amount of CPU and memory pressure, and sort of like do like inside the thing auto scaling. This is one of those things that I think starts to talk to some of the advantages of Nuclio, is that because it supports runtimes and it encourages runtimes that have this level of concurrency, you can get a lot more throughput, right? Anytime where you're doing load balancing to a sort of one at a time type of thing, you can actually get some really like strange behavior coming from the load balancer, especially when you have a distributed load balancer where you have, like, say, a fleet of ingress things coming in where they're actually not doing sort of a smart, up-to-date least loaded. There's actually Rab Genius, Heroku. They had, so there's this blog post from 2013, or gosh, I don't know, from forever ago, 2010. That talks about how Heroku moved to a load balancer that wasn't least loaded. They were redirecting to Ruby instances. Those Ruby instances were, because it's Ruby, were one at a time. And what happens is that you get backed up behind a bunch of things, even though you're doing sort of random load balancers. I believe as part of this, they did some really interesting simulations here, where this is perfect queuing here, this one's perfect queuing, but here's random assignment with servicing one at a time. And what you can see is that you actually end up with a lot of queuing, even though you have free things available. Whereas if you have perfect queuing, perfect assignment, then you essentially never get any queuing. This is an ideal, but it's actually difficult to do in a distributed way. If you have a single point of failure type of load balancer, you can do perfect assignment. If you're doing essentially random assignment, that scales horizontally well, and you can build more reliable load balancing. But when you actually have a one at a time for each of your backends, you end up with high latency here with respect to the queuing. By having the workloads themselves be able to handle some concurrency in addition to the concurrency of being able to scale out, you start getting latencies that look a little bit more like this. Sorry, going deep into queuing theory and load balancing here, but hopefully that's interesting. And I think that the fact that that's something that Nuclio is paying attention to is in my mind is an interesting thing and is key if you want to be able to get the high throughput numbers that they talk about quite a bit. All right, so I am like way over time. This has been 2 hours. I generally try and keep these things to an hour and a half. I feel like I still scratched the surface. There's obviously a lot going on with Nuclio. Thank you for Yaron and Aaron for joining. I really appreciate that. Thank you for everybody else for joining. Hopefully y'all didn't get bored. Hit the like, the subscribe button and the like button on the video. And let other folks know about what I'm doing with TGIK. I have a lot of fun doing this, and hopefully you all learned a lot also. And I will talk to you all next time. I'll talk to you later.